All right. Welcome, everyone. You are in here for a treat. All right. My name is Jamin Patel. I am the Senior Director of Product Management, leading cloud and AI security at Palo Alto Networks for the last 7+ years. And joining me, we have...
Hi, everyone. Yotam Ben Ezra. I run product for DSPM and AISPM within Prisma Cloud in Palo Alto. Joined about a year ago with the Dig Security acquisition. I was the Chief Product Officer at Dig. Pleasure to be here today with you.
Wonderful. All right. So let me just find out who is who in this room. Cloud security people, just raise your hand so that we know. All right, cloud security. Network security people, part of cloud security, but yes, I want to specifically know NetSec people. All right, they are there in the back. Developers. All right, I'll club DevSecOps part of developers, so if you have not raised your hand. Okay, so we have developers, we have cloud security people, we have network security people, so this is the perfect session for you guys. We are going to fight AI with AI, and kicking us off, we have Yotam. Take it away.
Okay, so thanks for coming today. Really appreciate the time, and appreciate you ending your day with us. It's 4 p.m., so hopefully we'll try to make your end of day interesting. So as I mentioned, I was a Chief Product Officer in various companies. I spent the last 20 years or so in cybersecurity, and I must say that we live in a very exciting time. Various industries are being transformed with the capabilities of AI. Whether you're in financial services, pharmaceuticals, government, AI is enabling productivity and effectiveness across those industries, and essentially that drives adoption at pace that we haven't seen before. So we already have thousands and thousands of applications, AI-infused applications out there. Pretty much every SaaS application today is already starting to get infused with AI. And so enterprises are adopting AI in multiple ways. We divide them into two main categories. The first one is employees which are using AI applications in order to do their day-to-day job, in order to do it faster, in order to do it better. The second one is enterprises who are building AI into their own applications. So we'll talk briefly about the first use case and then try to dive a little bit deeper into the second use case today. So essentially, for employees using AI applications, we have multiple applications in multiple fields. So we have people which are automating coding. We have people which are summarizing documents, and essentially people which are doing their day-to-day lives. But the number of applications out there are already thousands. And the security team in the organization would like to be able to control which applications are used, if those applications are reputable, if those applications are sanctioned as part of kind of legal usage in the organization. And also, I think probably the top concern, to understand or to be able to control what data goes into those applications. Because when data goes out, we have kind of no control on where it goes, and there is a major concern in terms of will we essentially have sensitive information going into those applications and leaving the organization. So AI access security out of Palo Alto Networks enables safe AI adoption for employees, generates automated visibility for thousands of applications, and allows you to essentially see how applications are used by employees, which applications are being used, how much are they being used, what are the top applications in your organization. On top of that, you're able to control which applications are allowed. So essentially, the ability to apply policy in terms of what type of usage you want to allow for an application. And once you allowed an application, to essentially control what data is allowed to go towards that application. So essentially, all of that control is available with AI access security. So with that, of course, I invite you to explore more, but our session today will focus on enterprises which are building AI applications. Now, if you're a typical enterprise today, you'll have your IT team building an IT assistant to facilitate faster resolution of cases. Your services team building support chatbots in order to provide better support to customers. Maybe application teams are building co-pilots for the different customer-facing applications. And maybe a few tens of other use cases which are happening in the organization in different stages. those are typically getting infused into the application infrastructure which exists in the organization. And that infrastructure, of course, includes AI models, right? Those are kind of the heart of the operation, but it includes a lot of other pieces as well. And each of those pieces introduces its own risk factor. So we have our AI models, whether they are managed by a cloud service provider or homegrown or self-hosted. We have a lot of infrastructure that's deployed as part of essentially running and building our AI pipeline. We have our data, which is the heart of the ability to essentially fit the capabilities of our AI models to the use cases that we are trying to run. We're typically massaging the data, formatting it, and infusing it into different parts of the AI pipeline. And we have different plugins and agents which are essentially facilitating transition of information between those different components. Now, each of those different components have potential security risks associated with it, whether it's at the infrastructure layer, the model layer, the dataset layer, or the plugins and agents layer. Each of those could have supply chain issues. Each of those could have misconfiguration issues. Each of those could have vulnerabilities, exposure. So what I want to do now is take you through a few examples of very common use cases, simplified a little bit, but very common use cases in terms of typical AI pipelines or ecosystems and the security risks associated with them. And later on, Jamin will take you through how these look when those models are actually deployed in production and are actually interacting with their end customers. So let's start. First one is an IT assistant agent. So an IT assistant agent will typically perform some of the IT operations and automate some of those parts. In this case, we're looking at an example where access management to some cases is partially automated. We have our end customers generating prompts to a model. There is a Lambda in the middle, which is essentially sending those prompts, sometimes enriching it with an IT documentation or an IT knowledge base data store. And that model will select which other Lambda to activate based on a decision which is happening in the model itself. Now, one of the most common attacks with cloud infrastructure, or one of the most common risks, is credential leakage. Credentials are being harvested by attackers, whether via vulnerabilities or via some other methods. It doesn't really matter. They might be purchasing them in a marketplace. But if they now have those credentials and are able to access the Lambda in our case, that means that they will have access to essentially interact with the model. That means two things. First of all, they have free access to our model. That is not cheap these days and can impact, if an attacker is using our model for their own purposes, it can impact in tens of thousands of dollars per day in expenses. But on top of that, it has been shown and seen that in some cases, attackers interacting with our models have been shown to try to exfiltrate sensitive data. So in our case, it's the IT knowledge base. It might have confidential data. And interacting with the model with different prompt engineering techniques might be possible to get a hold of that original data. So that's example number one, LLM jacking, attackers essentially hijacking our model. Moving on to the second example, we have a customer support chatbot. In this case, the architecture is a little bit different. We have our customers and prompts going into the pipeline. In this case, there is a conversation history which is saved in a DynamoDB that the Lambda is fetching every time it sends to the model. In this case, it's a self-managed model or self-hosted model which was trained using SageMaker in AWS. And we have a data set which is saving the training data, which was used to fine-tune this GPT-4, I think, model, and essentially fine-tune it to the use case. And then there is another bucket which stores the trained model. So as you can see, there are several data stores involved. And the first risk is an attacker or those data stores being exposed, whether via misconfiguration, via lack of awareness that those data stores are related to the model if we don't have this visibility in the environment. So if an attacker has an ability to write to the training data store, they essentially can create a data poisoning attack, essentially introduce bad data into the training data, and significantly impact the behavior of the model as a result. Now, it has been shown that actually attackers don't need to change a lot of data in order to do that. So even less than 1% of the data being poisoned can result in significant behavior changes if done right or wrong. I don't know how you want to define it. But we have additional data stores involved here. So first of all, someone could steal the model, the trained model, from that other data store if that is exposed. And that means that now they have our model, they can use it. It might be proprietary, it might be secret. And also, we have our DynamoDB database, which has all of the history of the prompt. So if we haven't secured how we store this conversation history, or if we haven't secured how we store the prompt interactions with this model, then we are at risk of losing that data as well. So essentially, data can be stolen from multiple places if we don't have the right awareness of how our AI ecosystem impacts our data or our proprietary data. So with that, I want to call Jamie to talk a little bit about what happens next. What happens when we are in production with this?
Right. Thanks, Yotam. All right, so Yotam talked about how AI applications that you have are subject to supply chain misconfiguration and data exposure risks. Let me talk about runtime risks that GenAI apps are subject to. But before that, let me ask a question. How many of you have GenAI apps in production today? Just raise your hand. All right, some, very few. How many of you will have it within a year? All right, about 20%. 2 years. In next 2 years. AI apps? All right. So based on our conversation with CISOs and CIOs and all of our customers so far, almost 100% of them will have GenAI apps in production in next 3 years at least. They are dipping their toes into it, and they are learning. We are educating them around the threat vectors and so forth. And these threat vectors continue to emerge. Like, let's talk about runtime risk here. We talked about AI application stack being extremely complex, and it is not same as a standard web app. Can anyone tell me what is the difference between a standard web app and an AI app? One difference. Right? You have some knowledge, but OK, let me clarify. AI app is also a web app, but it has more extended tech stack. That means it has models, which standard web apps may not be interfacing with. These models could be foundation or fine-tuned models. We have concepts of vector databases called inference datasets and training datasets. These concepts were missing in standard web apps. Here we have another tech stack called plugins and agents. These agents, autonomous or semi-autonomous, they were not there in the standard web apps. But every AI app is a web app, plus it has additional components added to it. That means an AI app is also subject to all the standard attacks that a web app is subject to, plus more. Okay? AI is not an alien. It is a web app. That means it is subject to all the standard foundational network attacks, supply chain misconfiguration, data exposure risks. All of them apply, plus some more. And these threats continue to come up. Here are some examples of what these new AI threat vectors are. For example, in AI infrastructure, your AI app that you are running in AWS, you would get some responses from LLMs. Imagine LLM is trained on pretty much the entire internet. They have a lot of knowledge, including bad knowledge, not just good knowledge. That bad knowledge could be in form of a malware that may get executed if the model spits that out. It gets executed on your app workloads. That's a malicious code execution. There is also prompt injection. How many of you have heard prompt injection as a terminology? Some, all right, yes. OWASP top 10 for LLMs. These are not SQL injections, these are prompt injections. the threats have moved from just signature-based attacks that standard next-generation firewalls were able to catch, to now those threats have moved to text, because these prompts are nothing but text. If it is multimodal, then these prompts could be in form of an image, video, and so voice, but these are prompts. All the threats are in the payload. These payloads, because of this unstructured data or unstructured nature of these prompts, it makes the threat vector completely unbound. In standard web app, you have very structured input, very deterministic output. In AI app, you don't have that. You have unstructured input, you have unstructured output, you have undeterministic output as well. That's why the threat landscape is different. Prompt injection is one such example, and I'll show you some demo around that. Model DOS attacks. The standard volumetric DOS attacks that we all are familiar with, where you are bombarding requests multiple times, and you can have a volumetric attack, or you can have a layer 7 DOS. In this case, none of those things exist. I can just do a simple model DOS attack with just a simple prompt to say, repeat this 1 million times. And guess what? Your AI app, if it is not careful enough, will go to AWS Bedrock 1 million times to generate the input, and your bill will spike up. So in the industry, this attack is also called as denial of wallet. Not necessarily denial of service, but it's a denial of wallet attack. That's some examples of how your models are vulnerable to some of these new attacks. Datasets. Yotam talked about data poisoning. This data poisoning could be at the time of training, when you are training the model with your proprietary data. Some poisoning could happen if you are not careful. Your S3 bucket is exposed to the internet and so forth. But there is also poisoning that can happen as part of your RAG application. Because when you are using vector database or tools and plugins to reach out to the internet or to get your knowledge base search done as dynamically as part of the prompt input, then I no longer have to attack. Previously, in the standard web app, the attacker will have to attack your system, your application, your infrastructure. Gen AI apps, they make it completely unbound. If you are using RAG application, that means you are reaching out to the internet to do some Bing search or Google search and querying the API, you will get malicious URLs. You will get the data poisoned at the inference time, not just the training time. Training time, you can still control a bit because it's in your control. At the time of inference, this is all live transactions happening. Okay? So that's a data poisoning attack. Plugins and agents. You will see a flurry of agents. You saw the announcement today. Matt talked about it, how AWS is advancing its products to introduce some of these autonomous agent building platforms and so forth. You will see a lot of autonomous agents. These agents need to be controlled. You will run into unrestricted communication between these agents and making the decisions autonomously. So these are the Gen AI apps. So agent world is a little far out. You guys are still going to take some time to move your standard Gen AI apps into production. But let's talk about standard Gen AI. This is the simplest version of Gen AI app architecture. You will have users talking to, let me see if I have a pointer that I can point to. You have users talking to the application workloads, which you might be hosting on AWS, EKS, and so forth. This app workloads will talk to the LLMs, and not just one LLM. We have, at Palo Alto Networks, we have our co-pilots for all of our security products. And we don't go to LLM only once. We go 5 times. And that's what is called compound system. Because LLMs are likely to produce more accurate outcome, given more context. So we gather more and more context, and we refine that context by going to LLMs multiple times before we send the response back to the user. That means that at least there is a fan out. User asks one prompt, which might be 80 characters, but behind the scene, we have 100x transactions going on in terms of characters and bytes. These LLMs, towards the LLM, you are subject to direct prompt injection and model DOS attacks. When LLMs respond back, this might be insecure output, or it might be sensitive data leak. And it's just a matter of you training the foundation LLM with your training data. Because there are a few people who are going to use foundational models as is, but not many. We are hearing from our customers that all enterprises will be using some sort of proprietary data to train and fine-tune the model to their specific industry and the domain they are in. So if you are doing that training with your data, it's just the question of when it gets leaked out, not the question of if. It's just attackers will use prompt injection as a mechanism to get the sensitive data leak out. Okay? Then you have tools and plugins that are connected to the LLM. These are the agents that can act autonomously. Or you might be using some plugins such as convert my text queries into SQL. Do this search, Google search or Bing search or any Amazon search. There also indirect prompt injection can happen where, in this case, the user is not doing prompt injection directly by interfacing with your app. Your app is going out as a RAG application, going out to the internet, and there in that Wikipedia or in a source, I have indirect prompt injection done. And you are just sourcing it and you are executing that query. Okay? So this is a standard runtime risk. Let's talk about some concrete examples. I have 3 examples of 3 different attacks, and then I'll do the demo after your turn. But here is an example of malicious URL given to a developer who is simply trying to ask a question that, how do I get the latest version of the software? It's a GenAI app. You are most likely to have developer productivity increased with additional GenAI components. Your GenAI app that gives developer some productivity boost is responding with this query on this query and just has a URL. It says, oh, here is the link. Because it was a RAG application, that URL was malicious. In this case, it's not a standard next-generation firewall's URL filtering capability, because you are not necessarily clicking on that URL. Your developer or your user is, but your application is just giving this output. In this case, it is your responsibility to make sure that your customers and your employees are not even getting this URL in the response. By the time they have to click it, it's too late. So in this case, enterprise AI applications need to block this. So that's the first example of insecure output. Second example of prompt injection. Prompt injection is not a one thing. Okay? I mean, you will hear a lot of examples. When we released our products, AI Security Posture Management, AI Runtime, and AI Access, in the month of May, when we announced it, we, as a company, knew about around half a dozen prompt injection techniques. When we launched these products in the month of August, there were about 12 techniques that we knew, about 1 dozen. Today, in just 3 months, we know about 17 techniques. So these techniques continue to emerge. So there are customers who are coming to me and say, is this just a simple goal hijacking where you're playing like a pirate and then you are telling prompt that forget all the instructions? It is one simple type of goal hijacking, promptly called jailbreaking, but it is not the only one. So it's very difficult for you to keep up with the pace of these threats because these threats continue to emerge and these techniques continue to advance on a monthly basis. Like I said, from 6 to 17 techniques, and God knows how many techniques would be out there in the world, and we continue to discover. Our threat researchers continue to discover more and more. And we have a public blog out there if you are interested in knowing more about it. So in this case, it's a prompt injection that is being used to say, let's do the simulation. If you ask a simple question like, hey, give me this account of somebody else, the chatbots are likely to deny that. But here you are instructing model to forget everything else, override the system prompts, and then you are tricking the model to do what you want them to behave. Okay? So this is a prompt injection. Direct and indirect are 2 separate types. Let's talk about sensitive data leak. Healthcare chatbot. Very easy to plug in LLM, super easy. AWS is going to make it super easy for you to adopt LLM and so forth. But in this case, this healthcare application just happens to train the model with some patient-sensitive data. Because it's in healthcare industry, can't use the foundation model as is, so they trained it. And somehow this patient PII information, PII got leaked into the training data. And you are able to, and models do hallucinate. They sometimes give you information more than what you ask for. So the question was very simple, that how do I treat this ABC symptom? But the model may end up responding with additional information that was not even asked for. And here you have a sensitive data leak. So our approach to securing AI. So it's a twofold. At Palo Alto Networks, we see AI and security as two sides of the coin, same coin. We not only use AI for security products, we also do security for AI. And I'll give you the example of both what we do. When it comes to using AI for security, we have over 4,000 machine learning models that are protecting customers every single day. We prevent 7.6 billion threats using our precision AI technology. And out of those 7.6 billion threats that we prevent across our customer base, 2.5 million or so are day zero attacks every single day that the world has not seen the day before. So that's the power of precision AI, which is the combination of Gen AI plus machine learning plus deep learning. And we use that AI across, we have built co-pilots for all of our security products across 3 platforms. We have Prisma, Strata, and Cortex. But we also do security for AI across 2 use cases that Yotam earlier talked about. AI access to protect employees accessing public SaaS Gen AI apps. And we do security for enterprise AI apps with AI security posture management and AI runtime. Both of these products start with the discovery. Because the number one question that we get asked from our customers is, I do not know how my employees are interacting with Gen AI apps today. I want to control it. I want full visibility and control and governance around that. I also do not know how many shadow AI applications out there that my developers have rolled out using LLMs, and I want to have a greater control and security around that. So AI SPM and AI runtime, we start with the discovery. You give us your AWS account, read-only permissions, and we'll show you the demo. But that's where we start. And then that's where both the products give you additional value. AI SPM gives you the protection against supply chain configuration and data exposure risks. AI runtime gives you inline protection, real-time inline protection against all the adversarial AI attacks that I talked about, such as prompt injection and model DOS and so forth. Okay? All right, with that, Yotam, let's do some demo time.
Thank you, sir. So in a few words, what is AI SPM and what does it do? So as Jamin mentioned, the first thing in order to be able to secure AI adoption across the organization, we have to be able to see it. And we have to be able to see it at the scale at which it is moving. We have to be able to see it at the speed of the cloud. So visibility into the AI ecosystem must be automated. And we provide full automated discovery and visibility into the entire AI ecosystem. Part of that is not only discovering the models and generating an inventory, but understanding the interrelationships between the different parts of our AI ecosystem and understanding how they impact each other. We saw earlier how important it is to understand what is the different impacts of the different parts of the pipeline, and that is essentially part of AI SPM. The second part is, of course, AI risk analysis. So for each of those components, the ability to look at supply chain issues, at misconfigurations, and exposure. And last but not least, data security across the AI ecosystem, whether it is training data sets, whether it is RAG data sets, part of retrieval augmented generation, any type of data store that is connected or impacted by our AI ecosystem is essentially secured as part of this solution. I think talking to a few hundreds of customers, both myself and Jamin have been talking to customers for the past 9 to 12 months around their AI adoption journey. And I think the number one concern that we are consistently hearing is the fact that since that relationship between data and AI ecosystem is not always clear and visible, the number one concern is, are we inadvertently exposing our sensitive data as a result of adopting AI? So with that, I want to move to a demo and share with you a little bit of how the solution looks like and works. Okay. Okay. So what you see here is the Prisma Cloud solution and my AI security dashboard. As I log in to AI SPM, I can see a summary of my AI ecosystem. In this case, I can see that I have 51 models which are running in my environment across 3 different clouds, I can see that 33% of my models are fine-tuned. So I can immediately get an understanding of how many of my models impact my own organizational data. Some of it will be sensitive, some maybe not. I will see that in a second. And we see a breakdown to the different components. So endpoints, which are instantiated of those models, different types of data sets associated and plugins as part of this ecosystem. I also get an AI security posture score as part of my dashboard that helps me track things over time and essentially make sure that I'm heading in the right direction. As we know, this environment is very volatile. It's moving all the time. The pace of adoption is very fast, and things are happening all the time. I want to make sure that my security posture is improving. So how do I do that? I get the top 3 risk issues that I have, which can impact the score the most. So if I'm asking myself in Monday morning, what should I do? That's probably the first one here. Another summary that we provide is data impact. So how many sensitive records of which types are impacted by training data, and how many are impacted by inference data or reg data? And I can see a summary of that here. I can also see my top assets in my environment which are at risk. And that is essentially based on a full inventory, which includes both my data assets, but also all of my AI assets or all of my AI models in my environment. So right off the bat, when I look at this inventory, I can see a few things. First of all, I can see all the different models that are used in my environment. I can also see which ones of those models are fine-tuned and which ones are base models. Some of the fine-tuned models will be found to be sensitive. So in this case, I can see I have a model, and it has PII or sensitive data associated with it. If I want to drill down and understand that impact, I can drill down. So in this case, let's look at an example of a base model. We have here a base model. We know it's Claude, and we see data sensitivity. If I click in, I can see that I have a Claude model. I can see that that model is instantiated to an API endpoint. And I can see that that API endpoint is associated with 2 vector databases as part of RAG processes. And I can see that those have been scanned, and we found various types of sensitive data. If I want to drill down and understand that data, I can go and explore the actual data findings and get a lot of details for each of those findings, including samples of masked data. So I can go to the original data sets if I want to clean them up, for example, and find that data in the original data set. What else can I say about this model? So first of all, I can see where it is, and I can see what data labels have been associated with it. As you can see, we infer data sensitivity to the model. Why do we do that? Because Jamie just showed that with a prompt engineering attack, an attacker might get to the original data, right? So we should treat models which are trained on sensitive data as if they are sensitive in themselves. I can see who created this model and who modified it. And I can also see the configuration, what type of guardrails are enabled for this model, what type of content filtering has been enabled, and I can enforce policy on that. I can also see risk. So in this case, what we have is not only that there is a sensitive inference data sets which are connected to the model. One of them is also ingesting data from an account that is not part of our organization. So essentially an account that doesn't belong to us, which means it makes us vulnerable to some sort of a poisoning attack as a result. So I can see here that the asset that is impacted is the actual data set, and I can see the originating account that is associated, or the bucket that is associated with the data ingestion, essentially. So this is one example of a risk, but what if I wanted to understand risk across the organization? So risk is also aggregated, and different types of risk findings are aggregated organization-wide across data and AI. And let's look at a few examples. So AI asset which is exposed, all of the AI assets which are exposed in my environment, some of them will be sensitive and some wouldn't, but even the ones which are not sensitive, we said that attackers can hijack them and essentially generate a cost impact for us. So if I go into one of them, I can see all the details. I can see why this is risky. I can see what type of frameworks it's associated with. So what type of control in OWASP Top 10 LLM, or what type of control in NIST 600 AI. I can see the asset that is impacted, in this case, the model endpoint. Or other examples, so training data set which is publicly writable. Again, data poisoning issue. So here we've identified that a specific bucket or training data set is associated with the model. And when we look into the details, we see impact on the model, but we also see impact on the data set. So what if I wanted to learn more about this data set? I can go all the way down, see all of the files which are associated with it, and the findings for each file. I can drill down and see the samples again and really understand the underlying data. I can also get a full overview of that data set and see what files exist in that data set as well, what files of interest exist, and of course, all of the sensitive data associated with that specific data store. Last example of risk that I want to share is another form of data sensitivity, which is not necessarily something you would think about immediately. So in this case, we are not saving our prompt logs well. So we have identified that we have some data store. We have identified that there is a procedure which is saving all the prompt logs from one or more models onto that data store. And that data store is exposed. So here we can see that as a risk finding, it's explained, and I can see all of the models which are impacted as a result as well. So essentially, there are various ways which our data can be impacted by introducing AI into the organization and by essentially building those complex AI pipelines. And the idea around ASPM is the ability to understand that relationship and understand the exact data impact in order to solve for that. Lastly, if we want to follow one of the relevant compliance standards for AI, so we have a full dashboard which allows us to track that. So we track the NIST AI 601 and the LLM top 10. This is the 2023 version. There is a 25 version which is coming out and will be in the system as well within a few weeks. So essentially, I can see how compliant I am, and I can see all of the issues that are associated with the different controls and how they impact my environment. So I want to finish this demo by showing what it takes to onboard and deploy AI SPM. So whether I deploy at the organization level or at a single account level, process is the same, super simple. I want to add an account. I will select a designated account for hub activities, data scanning activities, and will generate a template. It can be a CloudFormation or it can be a Terraform. Once I generated it, I can open it in my AWS console, approve it to run, and I'm pretty much done with my deployment process. Once I've done that, I will essentially start getting the insights populated into the dashboard automatically. Of course, there is a lot of customization available. We can build our own policies and customize to match our organizational policy as well, but there is a lot of out of the box as well. Okay, so with that, I will get Jamin to show the runtime part and share the demo of that.
Right, so I have a slide. Okay. All right, thank you, Yota. While you switch the laptops, I'll talk about one slide here. So that was AI security posture management, all about strengthening security posture across your configuration and data exposures and whatnot. Let's talk about the runtime. Both the AI SPM and AI runtime, we start with the discovery. Give us your AWS account with read-only permission, and we'll be able to discover your entire AI app ecosystem, including your application workloads, where they are running, which VPCs, what models you are running, fine-tune or foundational, plugins and agents, datasets, inference and training datasets, and everything. So we discover the entire AI ecosystem. And then we give you options. There are two options we'll talk about to protect against all these AI adversarial attacks that we talked about, all the runtime risks. There is a network-based approach, and there is a developer-friendly API approach. And after that, once we discover and protect, we do the continuous monitoring of because we have the account access in a read-only mode, we continue to scan your flow logs and DNS logs and any other prompt logs that you give us, so that if there are any additional runtime risks that pop up, we are able to give you the alert and give you the remediation actions. Okay? So with that, let me talk about the two types of options for the protection you have. So AI runtime security that we talked about, all the model DOS attacks and the sensitive data leak, insecure output, prompt injection attacks, we give you two choices. There are developers here in this room, may like one approach. There are infrastructure people here, the cloud security and network security, they like the other approach. Or sometimes you may want to use both. So the goal is the same, to prevent all the AI runtime risks. The first one is the network-based approach, where you are able to get the protection against not only the new AI attacks that we talked about, but also against all the foundational network attacks. So it is one product, one enforcement point, which is sitting in line at the network layer, where you are simply routing the traffic from your applications to the outbound internet, from your user to apps. It is one enforcement point that gives you the guaranteed enforcement and gives you the protection for all the types of network attacks. Who wants to deploy two products, one to secure classical network attacks and another one to secure AI attacks? Who wants to deploy two products? Nobody, right? Everybody wants to deploy one product, one. And it is the one product at the network layer that gives you the protection not only for AI apps, also for non-AI apps, because non-AI apps are not subject to all the new AI attacks. So we believe that you should not have security point products. You should have converged infrastructure, converged security products. Fewer products, the better when it comes to security. So it is one single platform that will allow you to do that, right? Because when we talk to customers, not a single customer tells me that I will have only 100% AI-only apps. Almost always, for foreseeable future, you will have non-AI apps and AI apps in your IT environment. You will transition more and more towards AI, but for foreseeable future, you'll have both. And you need one product that can do both. Okay? Now, the developer-friendly way. The same AI runtime security, the approach could be, hey, I already have a firewall on network layer enforcement point already in place. I don't want to change that. AI is an incremental threat vector. How do I address it in a non-disruptive way? And I'm building new AI apps anyway. Can you weave in security more towards shift left and when you are building the AI apps and AI agents and so forth? We provide AI runtime also as an API form factor, right now with REST API, single line of code that you can simply include in your app. When you receive a prompt, before sending the prompt to the model, just call our API, sanitize your prompt. When you are getting a response from the model back, before sending it back to the user to make sure it is not malicious, you can call our API to sanitize the response as well. Same security posture, same level of threat efficacy, just two form factors. One is a network level enforcement, another one is the API level enforcement. So now choice is yours. Both of them are consumable via the same licensing mechanism. Okay? All right. So the network AI security is this is what we do. We do the inline network intercept, so you are responsible for steering the traffic from your application VPCs before it hitting the model to this AI runtime security instances. It gives all the threat prevention. We have wildfire, we have sandboxing, we have URL filtering, DNS security, DLP. Everything is part of this. Plus, it gives you the AI app model and data protection. The second is the developer-friendly way of API. And what it gives is we help you with a simple API snippet, generates the API key, put it in your AI app code. You can be up and running, and you can be secure just in less than an hour of time. Right? So that is another way. And because it is model agnostic, you can, with an API, you can secure any public or private model. Even AI agents nowadays are being built on low-code, no-code platforms, where you may not necessarily have infrastructure access at all. In such cases, how do you secure your AI agents? Well, API becomes very handy, because in the event where you don't have infrastructure access to route the traffic to a firewall, calling an API might be an easy way to secure AI agents. Okay, and it also allows some sort of custom error handling, because we'll be able to tell you with an API response what is this error, what is the user level visibility, and you can do some UEBA. Okay? All right, let's switch to the demo. Two, one. Thank you. All right. I'm going to walk you through customer experience in 3 phases. So any customer who starts deploying AI runtime security will go through these 3 phases. Let me walk you through the discovery first. So this is the portal. You'll say, all right, I want to get started. We are at AWS conference. So you onboard AWS service account, give us the service account access. You download the Terraform that gives Strata Cloud Manager, which is our management plane, a read-only access to your AWS account, so we can call the APIs and start the discovery process. Once we have the service account created, we start discovering apps, all the data sets, models, and plugins, and so forth, and we populate the dashboard with all the inventory information. So here we have discovered about 21 applications, 10 models, about 135 different types of data sets. Your application workloads are standard web workloads, which are talking to the internet for various reasons. So we understand that there are 40 internet destinations your workloads are talking to just by scanning the flow logs and DNS logs that you may have. Then if there are plugins in place, we'll be able to identify that. We'll also look at your flow logs, so identify all the users that are interacting with your 21 applications. Now, we want to see, this ring is all red. There are about 21 applications, multi-cloud applications. We have the ability to onboard the account for any cloud. These 21 applications are talking to different types of models, but they are unprotected. They are not protected against all the prompt injection and other attacks that we talked about. So you add protection. You say, I want to deploy my AI runtime instances at a network layer. I'm giving you a demo on the network layer intercept. So you do and the same network intercept can sit between apps and models, apps and internet, between users to apps, and also apps to apps. So it is one enforcement point that does everything. You don't necessarily have to have different types of products between 2 endpoints. Here it is a one enforcement point doing all. So you can say, all right, I have models to apps and other traffic that I want to inspect. I want to deploy my AI runtime security in North America region. These are my 7 AWS applications that I want to protect. And here is the architecture. We show how we will deploy. We will create one security VPC. In security VPC, we will have a gateway load balancer instantiated, and we will put AI runtime, AIRS, as we call AIRS, as a auto-scaling group behind a gateway load balancer and then from your application VPCs, you will simply steer the traffic to our security VPC that is where the firewalls are all behind the gateway load balancer and auto-scaling. Very similar to our virtual firewalls that you have in public cloud. Now, we just give you a Terraform template that you can run. You can give to the developer team. They will run it. The security VPC is up and running in about 10, 15 minutes. And firewalls, while they are coming up, you can write some security policies. You know you have 7 apps, but now we call a policy construct called profile. There is an AI security profile for app, model, and data protection that you need to write. So for the AI, you have these models. You can do the access control for the models. If you do not want all applications to talk to all the models, you can specify that here. You can say that I want only certain applications talk to certain models and so forth. Then you can say for the AI models, do I want simply prompt injection to be alerted or blocked? For AI apps, what type of URLs I want to allow and deny. For AI data protection, we have over 1,000 data patterns out of the box. You don't need to, you can customize, you can create if you like, but we have ready-made data patterns available. Once you write the security policies and while the instances are coming up, you'll be able to see that 7 protected apps are communicating to these models and it's all protected. And you can take the similar step to protect the remaining 14 applications. Then when you go back to the security tab, you will be able to see that AI runtime security is sitting in between 2 endpoints and flows are blocking a bunch of threats and alerting you of threats. If the threats are alerted, it gives you the breakdown so that you can understand that I did not block certain critical and high-risk threats. It also gives you some recommended actions for you to take. Right? So this is the overall customer experience that you will see, starting with the discovery, then you do the deployment, and then you do the protection. Right? OK, so now let me show you the environment where we have a few apps, in this case 95 apps talking to some 8 models. And I want to give you some simple example of one AI app architecture that we have, and we have a few minutes left, so I'll be quick in this. So we have a demo setup on AWS, and we created a simple chatbot called Zephyr Bank, running on EKS. Uses Amazon Kyndra as a knowledge base, talks to the S3. There is a web crawler that continues to fetch information, and we are using Claude, right, as a model. But we could use any model for that matter. Right? So the steps are this. In this case, the user asks the banking service query, how do I apply for an auto loan? Then what happens is the banking application, the workloads running on EKS, goes to Amazon Kyndra to find out some information from the knowledge base. Then the application calls an LLM to determine how to answer this prompt, and with the retrieved data from Amazon Kyndra, and then Claude just simply generates the text outcome and responds back. Right? So this is the setup, and I just want to show you how I have 2 tabs open. One is the protected app, another one is an unprotected app. I have 2 tabs. This is the unprotected, this app. So if we simply ask the question, say, how can I apply for an auto loan on an unprotected app? This time, the data has been poisoned because we had access to that web crawler and the S3 bucket. So we have injected, it's called an inference data poisoning attack, not the training. This is the live RAG application just poisoned with some malicious data. In this case, it's a malicious URL. Now, I'm not going to click on this because I know this URL is bad, because I can go to Palo Alto Networks website and test this URL. It gives me that this URL is a malware. It is a site containing some known or to host malicious content. So I'm not going to click it, but your app is responsible to not give this bad output to your customers, because you will have a reputation risk if you end up giving this output. So we need to be very careful. But the same ones, I have the same app which is protected, and if I ask the same question, then of course I will get the answer, and this outcome should be blocked. But my point here was, I want to show you meanwhile, the AI runtime security is sitting between your application and model. In this case, we have AI runtime security. We have steered the traffic from my AI application workload before it hits Amazon, the Claude. And so while this is still running, just wanted to give you some perspective on where you will be able to see all the logs under log viewer. We have a bunch of logs that firewall has a lot of logs in general. So you go under AI security, and you will be able to see all the AI security profile logs, the ones that are blocked, the ones that are alerted, and so forth. Right? So there are logs here across model, app, and data protection. As you can see, that this URL that we gave as a response was a malware, and here is the URL. So all of this information will be available in your this one. So as you can see, I had unprotected app, which gave the response with the malicious link, but the same app that was protected, where AI runtime security was able to block such insecure output. And we have the similar instances, so many examples of prompt injections, model DOS, and different types of things. If you are more interested, we can have such a session at the later point in time. Okay? So with that, let me go back to the architecture. So AWS security reference architecture is like this. We will have the AI runtime running under security VPC. Your application VPC1 would be able to send the traffic for the inspection for your prompts and responses here, and then we will route the traffic to AWS Bedrock. Okay? We have all the models that are supported behind Bedrock. All the popular ones are already supported. If you're using API, you are model agnostic, so you don't need to worry about it. We have Titan and Claude and AI21, Cohere, Meta AI, Mistral, all the models supported. Right? Just to summarize the entire session, right? If you want to start with the discovery, we provide a very easy way to discover your AI app ecosystem. Whether your starting point is AI security posture management or AI runtime, the idea is for you to use AI SPM in conjunction with AI runtime and vice versa, so that you get the comprehensive protection across supply chain, misconfiguration, data exposure risk, and also runtime risk. Okay? The second is the simplicity of adoption. So we were able to demonstrate how AI SPM discovery and deployment is super easy. On AI runtime, also it's super easy to deploy with API or with a network-based approach. We just start with the discovery. We help you automate, give you the Terraform. You should be up and running within less than a day if you follow all the steps. And then with AI SPM and AI runtime with Palo Alto Networks as a platform, you have the broadest coverage across all the OWASP top 10 for LLMs. Best-in-class security I already talked about, and I cannot repeat this enough, where across 70,000 plus customers we have, our network security platform is preventing 7.6 billion threats, out of which 2.5 million are net new every single day. And we have 1,000 plus predefined data patterns for data protection. All of this best-in-class security from Palo Alto Networks you get with both the products. So with that, I want to thank you all for taking the time to attend our session. If you have any questions, we'll be here for a few minutes. But thank you so much.
Yeah, so we'll be waiting outside for questions. If you want to catch us, we'll be right outside the door.
Wonderful.
Thanks for your time, everyone. Thanks.